Hey, hi, hello guys, welcome back to Code with Nani channel. So today we're gonna discuss lead code problem of the day 1358. So number of substring containing all three characters. So you are given a string S containing only characters of A, B, C. So we need to return the number of substrings containing at least one occurrence of all these characters A, B, C. So if we take the example S equal to A, B, C, A, B, C. Okay. So, what is the total number of substrings that has all the occurrence of ABC? So we have ABC as well. First one ABC. Okay, cool. Then EBCA, ABCA. Then we have ABCAB, ABCAB. So if you carefully observe, we have all three occurrence of ABC. Here we have ABC here. We have ABC here. It shouldn't be like contiguous, but there can be non-contiguous as well, but there should be at least one occurrence of all these characters. Okay. Then when we have another ABC, ABC. Okay. In other case, we have a BCA, which is this BCA, BCAB, BCA, BC, CAB, which is this CAB. We have all the occurrence of ABC, CABC, CABC. Then another part of the ABC. This ABC. So totally we have 4, 5, 6, 7, 8, 9, 10. So that's the answer. So if you carefully observe the pattern behind it, so let's take another example as well, then you will get clarity. So here we have given AASCB. So we only have we only have three occurrences. So let's take this as one string. S1 will be ACB. Another string will be this one. S2 will be the AACB. Another string, substring, which is total string, AACB. Okay. So in this case, in each of this case, we have all the occurrences of A, B, C. So we have a 1A, 1B, 1C, and 1A. Even if you have more than one occurrence, it's entirely fine, but still occurrence should exist, right? We have two occurrences, totally fine. So A, B, C. So we have a B, C. So this is a total three substring possible for this AACB. So that's what we return. And another example, S equal to ABC. So we only have one substring that has all the occurrence of ABC, which is total string ABC. So that's why the one. So so if we carefully observe the pattern behind it, so what's the intuition to solve this problem? So as they mentioned it, so what we need to try to do is we need to find at least one A, at least one B, at least one C, and we need to count the total number of strings that exist with the occurrence of 1A, 1B, and 1C. So if you think in a brute force solution, you can do it in a n square solution, but that doesn't help because as you can see the constraints for this problem n is less than or equal to 10 power 5, so which does give you a TLE, so it's not helpful for us. So if you carefully observe and if you follow my previous videos, we can able to solve through sliding window very easily. So if we want clean explanation about how sliding window works or how we are implementing sliding window, you can check out my previous videos. So you'll get clarity about it. In this video, I'm just give you a brief about the sliding window and just go through with the code or intuition for this problem. Okay. So what does a sliding window does is, so there will be a two types of sliding window. One is static and another is dynamic. So in first case we know the size of the window. In other case we don't know the size of the window. So if you know the size of the window, how what you can do is you can directly check for the first window. Like suppose if you want to check for a windows of size k, first we'll check for the size k, and we'll increment from r is equal to k to less the some string dot length or like a vector or size. We'll increment each iteration by right pointer, and will increment the left pointer as well. So while you are moving the left pointer, we'll check for a particular case. Like suppose if you want to check whether it's a vowel or not, I'll check for a left pointer is a vowel, then if you want to decrement the count, we'll decrement, or if you want to increment, so whatever the things that requires for your use case, you will do that. So in each specific window, we'll check for the particular condition and we'll keep going on. So suppose if you don't have a specific window like this, in case we never know what will be the size of a substring that exists with a one occurrence of A, one occurrence of B, and one occurrence of C, right? So in that particular case, we need to check out from the left side until until when L reaches to the right side. Suppose we are iterating using the right pointer, right? Suppose until a specific condition exists, or until the left pointer reaches the right pointer, will decrease the window size. Suppose we have a window size of 7, right? Now and it forms our use case, right? Then what we can do is we'll try to find a solution that exists in between this window. Suppose window 7 size exists with 1a, 1b, 1c, then we'll try to decrease size of one of the left pointer as well. Now the size becomes 6, right? We'll check whether 1a, 1b, 1c present, then we'll decrement the size. So this way we'll check in the dynamic window size if we don't know the size of the window. So that's how the sliding window works on the dynamic window size. So coming to this problem, so how do we approach? So we can, if you carefully observe, we can able to find in a particular window whether A has been present, B has been, 1A, 1B, 1C has been present. Then how do you find the substrings? Right, that will be a good question. So it is tough to calculate the total substrings present using that 1a, 1b, 1c, but rather than, you can reverse engineer it. So how you can do, I'll explain you in this problem. Suppose if you have an example A, B, C, and you have a 3a as well. Suppose we find a window, right? So we find a window. Suppose we are L is here, R is here. Okay, so we find a window which has one occurrence of A, one occurrence of B, and one occurrence of C, right? So how do we find that total number of strings that has 1A, 1B, 1B, 1C present? So if you find a specific window, right, like this, then what you can do is you can reverse engineer it, which means that suppose what is the total length apart from this window exists. Apart from this window, we have a total length of 3, which is string dot length minus rth index, right? So this will be the length of that substring present on the right side of that particular string. So these many substrings exist. So how? So as you can see in this case, 3 substrings exist with this formula. How does that exist? I'll explain you. So in this case, A, B, C, A, right? So I'm saying 3 substrings exist with this particular occurrence of 1A on Wednesday. So one case will be A, B, C, A. Another case will be A, B, C, this A. Or you can say, no, it won't be a substring, right? The substring should be contiguous. So in that case, A, B, C, A. In other case, A, B, C, A, A, A. So 3 substrings exist. So what you can do is you find a specific window that exists our use case, which is 1A, 1B, 1C, and you will calculate the right, how many, what is the length of the right side part of the substring. So that many strings can be possible using this specific window, right? And as you increment the right side, so now the L is here, R is here. Now what you can do is you just simply increment right pointer. Now the right pointer is here. Okay. Now how many substrings? Now we need to decrement the left pointer as well. Now decrement the left pointer as it satisfies a window, right? Now how many substrings possible? As I told you earlier, you can just use the right side part of the length of the array, which is 2. So 2 substrings possible, which is BCAA, BCA, BCAA, BCAA, 3S, yeah, 3S. So with this window, we can two substrings can be possible. So if you take the window as a substring as well, then it will be ABC, BCA. Totally 3, 4, 5, 6, 7. 7 substrings possible until now. Now, if you move your right pointer to here and the left pointer to here, now there is no occurrence of B. Now the string becomes A, B, C, A, right? Now the strings become CAM, where it fails our use case, which means like we need to have one A, one B, one C. We don't have one B, so this doesn't. So this window doesn't give you a possible solution. Now increment right. Now the right is here and the left is here. Now check for this window. We don't have occurrence of B and C, so there won't be any substring present with this array. So the total number of strings, substring that can be possible for this particular string is 7, which is these three, these two, and these are the windows, which is ABC window and BCA window, so window of size. Window of A, 1A, occurrence of A, occurrence of B, occurrence of C. So total 7 has been present. So if you get this approach, so it will be easier to code. So what we can do is to keep track of these characters, we use hash map and we'll just increment the count and decrement the count in that until unless we have occurrence of A, B, C, map of A, map of B, map of C greater than 0. What we can do is we start decrementing the we'll start incrementing the right side pointer as well, and we'll start so as you see, as we are incrementing the right pointer, we will decrement the right pointer as well, right? So before decrementing the right pointer, if you increment the right pointer, we'll check for that specific case whether another substrings will be present or not. So when you start decrementing the left pointer, if we have a B as well, as you are decrementing the left pointer, what will be the length of the substring for this specific window? That will be the right side part of the array. Even you decreasing the right left pointer and you still making a specific window, what we will this specific window will make the total number of strings will be the right side part of the substring that is present on the right side of the, which means like total length minus the rth pointer. So I'll just show code you guys and you'll get clarity about the solution. Yeah, what you can do is, yeah, so what I'm doing is I'm just initializing the map of count, yeah, count character A as 0, character B as 0, and character C as 0, because in the question they mentioned we're only having a characters of A, B, C. So that's why I'm just initializing all the three characters with the 0. And this will be, L will be the left pointer, and count will be the total number of substrings that had been visited so far. So what I'm doing is I'm just starting my right pointer from 0 to h dot length and L space. As every time I visited a character, the count of that specific character will be increasing. At each iteration, I will check whether I found a solution or not. Whether I found a window of size, let's say any size, which has one occurrence of B, which means MP of character A is greater than 0, which means we found in our specific window we have a occurrence of A, and when occurrence of B is greater than 0 and occurrence of C is greater than 0, in that case, what will be the contribution of this specific window for that substrings will be the total length minus the rth pointer, which I told you earlier, right? So that will be the contribution of the right side of part of the array. Using this specific window, we can make s dot length minus r substrings, because at each character can be appended at the end of the specific window, and we can make a one substring which has one occurrence of A, one occurrence of B, one occurrence of C, right? So, and after we add it, we started, as it is a dynamic sliding window, we start to decrease this left pointer until this condition exists, which means one occurrence of A and one occurrence of B, one occurrence of C greater than 0. Until then, we'll start decreasing the left pointer, which means MP of S of L, which means left character, as we are incrementing the left pointer, which means we need to deselect or delete that from the map, right? So that's what we are doing. We're just decrementing the count of the left character and just we are incrementing it, and in the end we'll just return the count value. Let's just run the code. Let's just submit the code. Voila, it's submitted. And that's it for today video, guys. If you like my video, do subscribe to my channel and hit that bell icon, and you never miss any notification from my channel. And if you have any queries regarding my explanation or regarding my code, do put it in the comment section. I'll help you out, guys. And that's it for today video, guys. Thank you. Tata. Bye bye. See you tomorrow with a great content. Tata. Bye bye.